For over 50 years, no human has traveled beyond low Earth orbit. Since the end of the Apollo program, the moon has remained untouched by human presence. But now, that's about to change. NASA is preparing to send astronauts farther than any human has traveled in decades. Not to stay, not to land, but to prove something critical, that we are ready to return. This is Artemis II, and what happens during this mission will determine the future of human exploration beyond Earth. In 1972, the last humans walked on the moon. Since then, we've built space stations, launched satellites, explored Mars with robots, but we never went back. Not because we couldn't, but because priorities changed. Today, things are different. Space is no longer just about exploration. It's about technology, resources, strategic advantage. Countries like China, the United States, are actively planning lunar missions. The moon is becoming important again. NASA's response is the Artemis program. Named after the twin sister of Apollo, it represents a new era of exploration. But unlike Apollo, Artemis is not just about reaching the moon, it's about staying there. Before astronauts can land again, NASA needs to prove something critical, that humans can safely travel to the moon and back. That's where Artemis II comes in. Artemis II will carry 4 astronauts farther than any human has traveled since 1972. This will be the first crewed mission of the Artemis program, and unlike Apollo missions, this crew represents a new generation of space exploration. This mission isn't about landing, it's about testing, life support systems, navigation, deep space communication, human endurance beyond Earth orbit. Once launched, the crew will travel beyond low Earth orbit into deep space, a region where radiation increases, communication delays grow, and Earth becomes distant. But the most dangerous part of this mission isn't the launch. It's what happens when they leave Earth behind and enter a region of space humans haven't experienced in over half a century. Before humans can return to the moon, they need something powerful enough to take them there. Not just a rocket, but a system built for deep space. The most powerful rocket NASA has ever built. At the center of this mission is the Space Launch System, known as SLS. This isn't just another launch vehicle, it's the most powerful rocket NASA has ever created. Raw power. At liftoff, SLS produces more thrust than the Saturn V rocket used during Apollo. Over 8.8 million pounds of thrust, enough to lift the Orion spacecraft, carry humans beyond Earth orbit, and send them toward the moon. Why this rocket matters. Deep space missions require something very specific: escape velocity. To leave Earth's gravity completely, you need immense energy, and SLS provides exactly that. The Orion spacecraft. Sitting on top of the rocket is the spacecraft that will carry the crew, the Orion. Built for deep space. Orion is not like spacecraft used for low Earth orbit. It's designed to travel farther, stay longer, and protect astronauts from deep space hazards. Inside Orion, the capsule includes advanced life support systems, radiation protection, automated navigation, and manual control for astronauts. Every system is designed for one goal: survival in deep space. The service module. Attached to Orion is the European-built service module. Developed with European Space Agency, it provides power, propulsion, oxygen, and water. Without it, the mission wouldn't be possible. The trajectory. Artemis II won't land on the moon. Instead, it will perform a lunar flyby, traveling around the far side of the moon before returning to Earth.
the far side. This is where things become truly historic. The crew will travel to the far side of the Moon, a region never directly visible from Earth. Loss of communication. As the spacecraft passes behind the Moon, something critical happens. Communication is temporarily lost. For several minutes, the crew will be completely alone. Total isolation. No contact with Earth, no real-time support, just astronauts and the spacecraft. This is something no human has experienced in decades. Why this matters? This moment isn't just symbolic, it's a test of systems reliability, crew autonomy, and deep space readiness. The return. After completing the flyby, Orion will begin its journey back to Earth, re-entering the atmosphere at extreme speeds, faster than any human-rated spacecraft in modern history. Re-entry heat. Temperatures during re-entry can reach nearly 5,000 degrees Fahrenheit. The heat shield must perform perfectly. There is no margin for error. Every phase of this mission, launch, deep space travel, lunar flyby, re-entry, pushes technology to its limits. But even with the most advanced systems ever built, there's something NASA cannot fully control. Something invisible, something dangerous, waiting beyond Earth's protective shield. And it may be the biggest risk of the entire mission.
The rocket is ready, the spacecraft is built, the mission is planned. But once Artemis II leaves Earth, it enters an environment that humans are not designed to survive. Earth has something we rarely think about: a magnetic shield. Known as the magnetosphere, it protects us from solar radiation, cosmic rays, high-energy particles from deep space. Once the Artemis II crew travels beyond low Earth orbit, they leave that protection behind and enter a region where radiation levels increase dramatically. Radiation in space isn't something you can see. You can't feel it. You don't hear it. But it's there, constantly passing through the spacecraft and through the human body. High-energy radiation can damage DNA, increase cancer risk, affect the nervous system, impact long-term health. And unlike on Earth, there is no atmosphere to absorb it. One of the biggest threats comes from the sun. Solar flares and coronal mass ejections can release massive bursts of radiation. If one occurs during the mission, the crew could be exposed to dangerous levels in a short time. Orion is designed with radiation shielding, but here's the reality. It can reduce exposure, not eliminate it. NASA carefully plans missions based on solar activity, but the sun is unpredictable. A sudden solar event could happen without warning. Before reaching deep space, the crew must pass through another hazardous region, the Van Allen radiation belts. These are zones of trapped radiation surrounding Earth, filled with high-energy particles. Passing through them means a temporary spike in radiation exposure. The spacecraft will move through these belts quickly, limiting exposure time. But even brief exposure adds to total radiation dose. Radiation isn't the only challenge. There's also isolation. Once in deep space, Earth becomes distant. Communication delays increase, and psychologically, the environment changes. For the crew, Earth will shrink into a small blue sphere. No cities, no borders, just a distant planet. Humans evolved on Earth with gravity, atmosphere, protection. Deep space is the opposite. Every deep space mission involves risk, but without taking that risk, exploration stops. Artemis II is more than a mission. It's a test of whether humans can safely survive beyond Earth for extended periods. Because if something goes wrong out there, there's no quick rescue, no immediate return, just distance and time. And despite all the preparation, all the technology, all the planning, there are still unknowns, variables NASA cannot fully predict. And as the launch date approaches, one question remains: are we truly ready to go back?
Artemis II isn't just a concept anymore.
It's real, it's scheduled, and every step toward launch is being watched closely. As of now, Artemis II is targeted for launch no earlier than 2025, but like all complex space missions, the timeline has changed more than once. Deep space missions are different. Every system must work perfectly. Even small issues can lead to delays. NASA has taken extra time to improve safety systems, refine hardware, and analyze data from Artemis I. The uncrewed Artemis I mission provided critical data. It successfully sent Orion around the moon, tested deep space systems, and returned safely to Earth. But it also revealed areas that needed improvement. Since Artemis I, NASA has been working on heat shield performance adjustments, life support system refinements, software and navigation updates. All of this is aimed at one goal: ensuring crew safety. NASA has already selected the astronauts for Artemis II. The crew includes 4 highly trained individuals: Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. This mission marks several milestones: first woman to travel to the moon's vicinity, first black astronaut on a lunar mission, first Canadian astronaut traveling beyond Earth orbit. Artemis II represents a new chapter in space exploration. This isn't just a NASA mission, it's global. Agencies like the Canadian Space Agency and European Space Agency are playing key roles. The Artemis program isn't just about returning to the moon, it's about building a long-term presence, including future lunar bases, Gateway space station in lunar orbit, and preparation for missions to Mars. Artemis II is just the beginning. The next step, Artemis III, which aims to land humans on the moon again. Even with progress, challenges remain: budget constraints, technical complexity, and schedule pressure. Space exploration is never simple. We're watching something rare, a transition from low Earth orbit back to deep space exploration. Artemis II isn't just another mission, it's a test of technology, of human endurance, and of our ability to go beyond what we've done before. Because if Artemis II succeeds, humans will return to the moon. But if something goes wrong, it could delay deep space exploration for years, and the future of human spaceflight may look very different.
For decades, humanity has remained close to Earth, orbiting it, studying it, watching from a distance. But Artemis II changes that. Deep space is 1,000,000 times bigger than the area around Earth. This mission is more than a test flight. It's the moment humanity begins to move outward again, beyond satellites, beyond space stations, back into deep space. The last time humans traveled this far, the world was completely different. Technology was limited, computers were primitive, and space exploration was driven by competition. Today, it's driven by possibility. Artemis isn't just about flags and footprints. It's about building something lasting, a sustained human presence beyond Earth. The moon is no longer the final destination. It's a starting point, a place to test technologies, learn how to live off Earth, prepare for deeper missions. Everything learned from Artemis II feeds into a larger goal: sending humans to Mars. A mission far more complex, far more dangerous, and far more distant. But even as we look forward, the risks don't disappear. Deep space is still unforgiving, unpredictable, and largely unknown. This is the moment we decide: do we stay close to Earth, or do we push farther into the unknown? The astronauts aboard Artemis II are not just traveling to the moon. They are proving that humans can go beyond Earth again, safely, reliably, repeatedly. When they look back at Earth, they will see something few humans ever have: a small, fragile world suspended in darkness. Every major step in space exploration has changed how we see ourselves: the first orbit, the first moon landing, and now, the return to deep space. Beyond Artemis II lies uncertainty. Missions that haven't happened yet, challenges we haven't faced yet, discoveries we can't predict. This mission is not the end. It's the beginning of something much larger. Somewhere beyond the moon, beyond the reach of our current missions, lies a universe still waiting to be explored. And for the first time in decades, we are preparing to go back. The question isn't whether we can return to the moon. The question is how far we're willing to go next. Subscribe to Obscura Cosmos, because this mission is just the beginning, and the next step might take us farther than ever before.